We are live. Welcome back to Encodes, everyone. I'm Nate. Let's code. And today we'll keep it rolling with day 2 of Advent of Code. So yesterday I built a solution for day 1 of Advent of Code, and if you'd like to see that solution, I push it up to my repo here. But today I'll be tackling day 2. And again, for this year's Advent of Code, I'm going to be approaching the solution using a test-driven development approach with Typescript. So essentially each day I'm setting up a sort of a mini Typescript project with npm and just for tests. But without further ado, let me jump into today's problem. So just to give the play-by-play from yesterday. Essentially, the theme for this year is that we're sort of throughout the month of December trying to solve a problem with snow production, global snow production, and Santa and his elves have enlisted us to find that solution. And each day, again, how Advent of Code works is we're presented with sort of a smaller problem. Yesterday, essentially on the first day, the elves were sort of launching us into the stratosphere using a trebuchet, but there was a problem with their slingshot, and essentially we had to write a nice little program here in day 1 that essentially ingested some data for the trebuchet that looked like this, essentially just a large text document. And basically we needed to extract numeric characters from each one of these lines of text and basically do some math with it. So some fun string manipulation, and yeah, hopefully day 2 will have another fun challenge here. So for day 2. Oh, and again, each day when you solve the problem, you get a little gold star. So we've got our day 1 star. Let's jump over to day 2 now. Alright, let me talk through the problem here. So again, we succeeded in fixing the specs document issue that the elves had yesterday, and we're good to go. So day 2, cube conundrum. And reads as follows. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you have arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? So right away, getting some creep vibes from this elf on Snow Island, some Jigsaw vibes, that he wants to play a game with me, but we'll roll with it. And again, the kind of fun thing about each one of these challenges is that it's sort of like a word problem, so it's sort of incumbent on us to kind of separate the wheat from the chaff, and there's obviously a lot of red herring information. It's like we're a hound dog on the hunt, but someone's sort of laid a red herring across our path to lead us off the track. But again, in any kind of problem solving, there's going to be a lot of irrelevant information. So again, we're trying to get to the crux of the problem that we're trying to solve. But with that said, as you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Bag of cubes. Cubes are red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. So there's red, green, blue cubes. There's going to be sort of an unknown number of each one of those 3 colors that gets thrown into the bag. To get information, once the bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. So again, this game consists of him randomly pulling cubes from the bag. So I assume they're random to him, so he's randomly pulling them out of the bag. You play several games and record the information from each game, your puzzle input. Cool. Again, each day we're going to get some puzzle input, and that's sort of the raw data that we need to work with. Each game is listed with its ID number, like the 11 in game 11, followed by a semicolon separated list of subsets of cubes that were revealed from the bag, like 3 red, 5 green, 4 blue, commas between each. So for example, the record of a few games might look like this. Okay, so what they were saying is these games are gonna have indices. So game 1, game 2, game 3. The data is formatted like game whatever number, colon, and then there's gonna be sets of pulls from the bag that are separated by these semicolons. And it appears to be, so for instance, game 1, there are 3 sets. And in the first set, it's 3 blue, 4 red. Second set is 1 red, 2 green, 6 blue. And then the last set was just 2 green. So it looks like there's an inconsistent number of sets. So this is something we're going to have to deal with. But yeah, each game, we could probably assume that there's going to be at least one set to consist. We might be able to assume that a game consists of at least one set. Otherwise, it wouldn't be a game. And each game, again, is gonna the elf may pull some of each color, may just pull one of one color. Yeah, again, it's because it's random, and all the cubes are kind of jumbled up within the bag, and it's a random selection. We're not going to know. Again, this is kind of the total, so the elf will kind of reach into the bag one by one, pull things out, but at the end of each set, this is the total of each one of them. So kind of they be pulled out of the bag, kind of piled up. But yeah, again, and furthermore, it looks like the number of pulls. So for instance, the 3 and 4, the total of this is 7. This one's 8. This one's only 2. So again, in any given set, looks like there's kind of not. We can't assume any particular number. It's not like each set is they're gonna pull a batch of like a dozen cubes. It's so each game is at least one set, and there could be any random number of cubes that get pulled. But again, this is our raw data, but we're going to need to read further here because we need to parse the relevant information. But again, here's kind of a breakdown of how to make sense of reading this raw data. So for instance, in game 1, 3 sets of cubes are revealed from the bag and then put back again. The first set is 3 blue cubes, 4 red cubes. The second set is 1 red cube, 2 green cubes, 6 blue, and the third set is only 2. So again, that's what I was just kind of running through. Now, the elf would first like to know which games would have been possible if the bag contained only 12 red, 13 green, and 14 blue cubes. Okay, so now we're getting into possibility of games. So, and this is going to be kind of one of our operating assumptions is that, all right, well, let's imagine that, again, because right now we really didn't have any information about, this bag, what's consisted within it, how it's being filled up. But here's an assumption now we can work off of is, all right, each bag, there's only no more than 12, no more than 13, no more than 14 red, green, and blue cubes. Okay. So in the example above, games 1, 2, and 5, 1, 2, and 5, would have been possible if the game had been loaded with that configuration. Okay. However, game 3 and would have been impossible because at one point the elf showed you 12 red cubes at once. Similarly, game 4 would also have been impossible because the elf showed you 15 blue cubes at once. If you add up the IDs of the games that would have been possible, you get 8. Okay, so there was a bit of irrelevant information there pertaining to, all right, how many sets, yada, yada, yada. The problem we're actually trying to solve here is we need to separate between possible and impossible games based on this criteria. So again, you can kind of imagine that maybe we have this record, but these records are unreliable, and it's kind of like we need to write a program to sort between reliable records and unreliable records. And again, something like this could you could imagine happening. It would be easy to sort through manually if there were like 10 games that happened. But if there were like 10,000 games, it'd be really helpful if we could just write a program that could check this for us. And either way, again, it's important to recognize that some irrelevant information, some relevant information. The problem we're actually trying to solve is sort of embedded in this situation. So again, really what we're trying to do is, based on these criteria, examine each of the constituents of each game, and then really it's just going to be a matter of looking for red flags that would determine if the game was impossible. So cool. Now, however, the final answer that we need to submit, though, is if you add up the IDs of the game that would have been possible, you get 8. So the format that we actually need to submit our answer in is, all right, we need to write a program, separate out all the impossible games, and then we actually need to go through and add together the index number of the games itself. So maybe a little strange, but that's just so happens to be the format in which we submit our answer. It's not that at the end of it we're submitting all the possible games, just kind of with the impossible ones removed in a list like this. No. It's that we need to somehow create that list of the possible games, but actually we just need to create a list of the IDs of the possible games as numbers that we can just add together as a sum. So if you add up the IDs, that's the crucial thing here. Add up the IDs of the games that would have been possible, you get 8. So, again, to summarize it here, determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, 14 blue cubes. What is the sum of the IDs of those games? Okay. And then here is some raw data for us to test with. Again, as you can see here, this is way more than just a few games. There's actually 100, some arbitrarily large number, which is why we need a programmatic solution. So I'm going to go ahead and copy just the text of this. And in my repo, again, recall the structure I have here is that each day there's going to be some data. There's going to be some source, some TypeScript that I actually write and test in the source directory that gets going to get compiled. I wrote some scripts to actually run that code. We'll get to that in a moment. But then each day has a README, and let me just record the problem statement for day 2. Now what I had done yesterday was kind of lay out some of the my to-do list, so to speak. So I'm going to do something similar. And I also have that getting recorded right over here. Okay. So my solution steps are going to be files and tests. Okay, so then what I need to do is I'm going to write some pseudocode. So what would be a pseudocode sort of approach to this? Well, again, pseudocode is we're not writing actual code. It's basically just a way to help us get a sense of what the solution would generally look like. So again, I think our problem is going to involve recording, our max cubes for each color. Now, again, right away, distinguishing that is going to allow us to, again, what if we were in a different situation where there's a different composition of assumptions we can make about the total of each color. So, again, it'd be, we could write our whole program, but if it was just hard-coded like 14 each time, that'd be pretty useless if we had a different situation, right? So, basically, I think we're going to want to have a couple steps here. I think we're going to want to cube color max for red, green, blue. I think we need to, I think the real core of this program is going to be we need to define a is game possible function. And again, this is going to be a function that detects if the game is possible or not. So it's going to kind of rely on sort of a Boolean value. So what that's going to consume is this raw game text. Again, we're going to have to do some string manipulation over here. And actually, I collect this raw data because that's what we're going to use to prepare our solution down here. So I'm just going to collect that into my data folder for, I'm just going to call it input.txt for day 2 under my data folder. Save that. So it's going to consume that. It's going to read that from the file. But then we could also pass into it, the max red as parameters that could change. So these are going to be kind of constant variables. But then, again, we could pass those as parameters. So this function would end up being agnostic about, what these are, and then we could just set those parameters however we like. So, but the actual arguments could be whatever numbers. That would be very helpful. Okay, so then we're going to need to do some string manipulation. So that's state 1. We're going to have to do some string manipulation so we kind of look at each game. So again, it consists of these sets. So we're going to string split on the semicolon character on each one. Okay. Then we're going to write some kind of, loop. So for each, we'll call it string split on to get list of sets. For each set, basically what we need to do is we need to count num red, num green, num blue. And then we need to check against max params for each color. And then we need to return, basically, for each one of these, we need to return false if max param is less than the actual num of the color. And we could kind of write this in the opposite, so we could have it return true if if it was the other way around. So if params was greater than num color, but whichever way we want to do it, then at the end we're going to return. If we did it this way, then we would be returning true. Basically, if none of these were false. If all num colors pass true. Again, we could set this up, the other way around. So, again, this function we're calling it is the game possible. So we want to turn true if it was possible affirmatively. Again, we could do that in the opposite. So if we were trying to detect is game impossible, then we would return true if these were all false. So again, it's a binary state that we're trying to detect, but and again, it's just whichever way is convenient for you to detect this. So, but again, it's a binary state. Most important thing. So from that, again, we're gonna want a basically. So this, again, it's kind of like we're gonna run this on. We're basically going to count the cubes. This will be a function, count cubes. And it's going to take in each set as a param. And basically, we could just say that we could kind of init red sum, green sum, blue sum. We can kind of init all at 0. So it's kind of like we're going to tick up if when we examine each set, basically, it's just basically going to return the total count of those. So it's going to be kind of a helper function, but then basically, once we have that list of games that were possible, we're basically going to have a sort of a more main function that uses this as a helper function, is game possible. And what it's going to do is sum possible game IDs. Okay, so that was really critical because basically, and it's going to consume, we could just say games data. But again, it's really critical because the format, it's not just enough for us to detect, game 1 possible true. We basically have to extract the ID number, parse it as an integer, and then have that as a running total for the sum of the IDs. So basically, we're going to init sum 0. Okay, that's going to be like our running total. And then, again, this is going to be, we'll call this game text data, because again, what's going to be going in here is all this business. So on each one of them, basically for each game, we need to extract the IDs. Run this function, and it's going to be like a helper function. It's impossible on that game. So if game possible, if game is possible, that returns true, then we're basically going to do something like sum plus equals game ID, something like this. And then at the end of this all, it's going to return sum. And that's the final answer that will get submitted in here. All right, cool. Well, that's pretty much the lay of the land. So let me jump into writing this code here. All right, so I think what I'm going to start with is basically, again, we're using Jest and Typescript. So check out my last video if you'd like to see how I set up each one of these configuration files. But suffice it to say that essentially we are going to use Jest to look inside the source directory. So let's start by defining a game.test.ts. Okay, so this is where we're going to write our tests. So again, test-driven development, basically we need to write failing tests that we then write our source code to pass, that then we can refactor. So red light, green light, refactor. So this test file, basically, we're going to need it to import this file. So we're going to just call this game.ts. And out of this file, I might just dock this input data just kind of down here so I can kind of see that to the side. But basically, what I want to do is, from my pseudocode, I mocked up these different functions that I'm going to need to write. So is game possible, count cubes, some possible game IDs. So I'm going to start by doing export this function, some possible game IDs. And what this is going to accept is basically this raw game data. So it's going to accept basically an array of strings and then the max number of these parameters that we want to have, and then it's going to return a number. It's going to return a number. I actually might dock my pseudocode down here for quick reference. So basically, and we're going to want to take in as params these. Actually, I think, so I wrote this one first. I'll just kind of do it down the line. as we had written from our pseudocode. So actually I'm going to write this export is game possible. I can just copy this right out of my pseudocode. Export function is game possible. So raw game data text is a string. Max red is going to be a number. Each one of these three other params are going to be numbers. Number, number, number. And then the return type is going to be a number that's coming out of here. It's my mistake. So this basically is possible. It's going to return true or false, right? A Boolean. Okay. Let's just set that to the side for a second. But next, I'm going to want to have my test file set up. So here's my test file. I'm going to import this function and this function from game. Okay. Now I'm going to define basically a test suite. So basically this is going to be to describe. Essentially this is just going to be a written label that I want to see when I run this in my terminal. I'm just going to clear this. So I'm going to call this cube game tests. So this describe block is going to kind of run at the top of my test report. That takes a callback as a second param, and then now inside here we can actually write our tests. So I'm going to write two tests. In my test suite. And again, what goes inside here is just a written description of what this is testing. So basically what I need to have working is that it should correctly check if the game is possible. That's all. And my second test is basically going to should calculate correct sum of truly possible games IDs, right? So again, once we have a game, we actually need to take the sum of its ID. And again, that may seem kind of weird for whatever reason. It's not that we're like taking the sum of, all the cubes or anything like that. We just need, again, this is an arbitrary ID, but that's what we need for our final answer, is to take the sum. If it was game 28 and 30, we need to add those to the running total. Okay. And actually, what I'm going to do is copy this example for my test case. So again, any good test-driven development is going to abide by the AAA testing procedures. So we need to arrange, act, assert. So first I'm actually going to arrange this example. I'm just going to call it game data. And I'm going to, well, after this is all said and done, what I'll have is basically each of these, I'll read this text file from my hard drive, and I will just create an array, and it will be separated on the new line character. That's what I did for my last solution. So basically I'm going to make an array, and each one of the lines is going to be the big long string for each individual game's data. And what that's going to look like is something like this. So just for this example, so again, what I'll write in a moment is basically pulling this whole text file, but then breaking it up via new line character. I'm gonna have to chop this down a couple different ways. That's kind of the first pass of the knife is, all right, first I need to ingest it and chop it via new line characters and break that into an array. And eventually I'll get into chopping it into sets via the semicolon separator. But right now, I'm just arranging this test example for my tests. And what I can also do is, there's a great feature in Jest where basically I can run the test on each one of these inputs. So this is kind of like it's an array of inputs. So what I can actually do is, off of test, I can do dot each, pass that in an array of test data. And what I can then do is basically pass into here another param, which is actually where I'm going to be doing my assertions. So that's going to look like is game expected, the expected outcome, fat arrow. And basically I can pass in something like this. So what it's going to look like is, it's an array of arrays. So I'm going to make an array for each one of these. There's 5. 1, 2, 3, 4, 5. So what I can do is, okay, the game is going to be this raw data. So I'm going to do, in this array, game data index 0. And what I know about the expected value of 1 from here was that it was passing. Yes. So in the example above, games 1, 2, and 5 were possible. So right now we're just checking if they were possible. We're not even looking at this final step that calculates them correctly. So expected, true. It was 1, 2, and 5. The others were impossible. And it's going to be this format for each index in this game data array. Game data 1, 1, 2, and 5 were. I could do it like this. I'm just going to list them all out like this. So game data index 1 is the second, the third, the fourth, the fifth, and it was 1, 2, 5. So these two should be false. Cool, cool, cool. So again, these inputs correspond to this array of arrays, and each array has these two values, and we're capturing those in our actual tests. And then we can basically dispatch, so that was just all an arrangement, but now we can actually, the action is going to be isGamePossible. We're going to be calling the function isGamePossible. This is action. And again, TDD. So isGamePossible, it takes in the raw game text, and then the three parameters for the corresponding to the three colors. So we're going to hard code that in, but the game parameter here is this game, this particular game, this particular game. So it's that raw data. I'm able to chop it up to present it to my test like this. And then each one of them, it's 12, 13, 14. Right, because max red, green, blue, in that order. 12, 13, 14. So that's the action. And this is going to return true or false. We haven't got there yet. But arrange, act, assert. So my assertion is expect the output from this function with all this input, I'm going to expect that to be expected. The true or false value that, again, this is a way for me to line up like multiple tests at once. So what I'm going to do now, I can run my tests from my npm script and cd into day 2. I can run npm run test. So let's see what happens. Great, it picked up that test. Awesome. Red light, that's what we wanted. Red light, green light refactor. So, well, it's throwing, it's failing because it threw some actual runtime error with TypeScript. It's not failing because we wanted it to fail. So we'll look at that in a second. But I'm going to have my just test suite running here, hot reloading each time I make a change. So what I'll do is, again, these are the watch settings. I can just have it each time. I'm going to do F for run only the failing tests. Oh, actually, well, it didn't fail because I wanted it to fail. It failed because of this type error. Let me fix that. I'm just going to comment out this function that I wrote there. Actually, well, I could just have it return 0 just to get this running. Let's try that again. Okay. And it's for this second test, should cal correct. I'm just going to comment out this for a second. All right, so now Jest is actually up and running properly. And what I might actually do is I might just drag this up here. Well, basically, it's running properly. It's boom right here. So this is our describe block. Cube game test, and it ran that this test 5 times for these 5 inputs. Again, it was kind of like running the same test, but on these 5 inputs. Should check correctly if possible. Now, one thing I can actually do here, I want to see if I can do this. We can actually embed using this syntax. Basically, what that does for us is it embeds the test data, boom, right in there. So we can actually see that it was this right here. Boom. So 1, 2, and 5 passed. 3 and 4 failed. And this is very useful because it's going to actually show us the raw data that we were dealing with. Cool. And it failed because we don't actually have our logic written yet. So red light, green light now. So let's write the actual logic of this function such that it will do what we want it to do. Okay, so again, recall it's going to take in each game like this. And remember, in our pseudocode, first thing we want to do is basically extract the sets. We want to chop out the sets. So it's going to be raw game text dot split on each one of these semicolons. Boom. Cool. And that hasn't changed anything here. What I could also do is I could also set up such that over here I could run my dev script and compile this game and then run that compiled JavaScript code. So it created dist, it created game.js. I actually don't want these test files compiling here. So what I wanted to change is these should be getting excluded. I'm not sure why it's not getting excluded. We'll roll with it. But basically, I don't want to compile my test file. Let's see. It is test. What if I did it like this? Game.test. Still compiled. Game.test. Whatever. Whatever. Let's see what happens. Compile that. Still compiled. Let's see. Why is this not getting excluded? I think my problem is I think I want to actually, in the name of this test file, do spec.test. Whatever it might be. I think that's will be reserved. No, actually, I did not format this wildcard correctly. So what it should be, again, it's going to be TS, but what I actually want is ** single star. So the test could be named whatever, but if it ends with .test.ts, that's what I wanted. Yep, it doesn't get compiled there. Great. But if we come back into here, what we can now do is console log our sets. Let's see. I'm going to close this window. Great, okay. Sets. Now this is busted out like this. Now, however, this doesn't make sense because, so for instance, the first set is going to have this game also included, which is not what we want. So what we want is, so how can we solve for this? Well, basically, one assumption we could make is it's going to actually, each set is going to be separated by boom, boom, space. So what we could do is, well, actually, I think that'll be fine for right now. What I actually want to do is down here, I'm going to have a helper function. It's going to be count cubes. Now what this is going to take in is an individual set. So we're going to call it up here in a second. So in this function we're going to iterate through, but each set is just going to be a string. And what it's going to return is an actual type that looks like this. So I'm actually going to define a type here. We're going to call this cube set. And each cube set, basically when you define a type in Typescript, you can have, it's basically going to define an object, and basically it's going to be defined by us, but it's basically going to be basically a template for an object. So it's just going to be these three numbers. Number as an object. Right, so it's going to return to us this type. So basically we want it to return us an object in this format. Now, we're getting a type error. It says a function whose declared type is neither void nor any must return a value. And again, basically the problem, the error we're getting here is that we're not returning an object of this shape yet. So again, the input is going to be color counts. We'll do red, green. We're basically initializing this object. Return color counts. It's supposed to be a const. See? So again, that's basically just initializing this object. and we're just immediately returning it, but it's going to now satisfy this return type constraint. Cube set, boom. Okay. So what do we want actually to happen in this function? Well, we're going to do some, like in the first day one problem, some string matching. So const parts, we're going to take this set, individual set, and we're going to match a regular expression throughout its entirety, so it's going to be global. And what we're going to want it to do is it's going to match a digit, one digit or more, and it's going to capture a pattern like the text red or blue or green. So basically it's gonna look through each one of these. It's gonna be some number, space, and then some label like red, green, or blue, literally the text. Some number, space, and then some text, red, blue, or green. So what we can now do is console log parts, and we're going to actually call this function. Actually going to move it up here. So we can see right away where it's getting called. So count cubes is basically in charge of counting up, each one of the sets, but it's an individual set, but it's going to get called in is game possible when we're iterating over each of these sets, right? So what we'll do is here we're going to iterate over these sets. So we can do something like for set of sets. Basically, for each one, we want to invoke this function. So we can do const. And again, we're going to be able to get this cube set type. It's basically just an object with red, green, and blue totals. So I'm going to pull out red, green, blue. I'm just going to destructure those. When I invoke count cubes on that individual set. Sweet. Now what we want is basically, so we can get rid of this now. So right now it's just returning true all the time. But actually what I might want to do is also log .log all this business. So again, in our test file, it's going to process this now. Oops. Okay, so check it out. So for this game, game 1, 3 blue, 4 red, broke up all the sets, but now the parts is null. So why is parts null? Let's check it out. Parts was right here. So each set. So yesterday we ran into this problem with match where if it does match, it will populate an array of each of the matches. But if there is no match, then it actually returns null. It doesn't return an array. So right now, it's not matching any of these. So this is where it gets tricky because we don't want it to just be a digit. We want, because again, it could grab this game 1 digit. We want let's see here. So, for instance, if I remove this piece, oops, put this back here. Okay, if I remove this matching piece where it's actually matching for those strings, this is what's going to happen. Parts D. So what's going on with this? So I think what it's doing is parts D. What is happening here? We'll switch it up like this. Basically just look for digits. So right now, right now it's matching the string D. So actually I want to do backslash D. That was my problem. This is the actual directive, the regular expression directive. All right, get me these numbers. Okay, but here's the problem. Again, this is why this is a tricky coding challenge because again, right now it's busting out this first set. It's also including the game number, and that poses a problem to us because we actually don't want to include that. So what we could do is we could do another split. Basically, this is what's preparing each of the sets for us. So we could take this a couple different directions. We could change this up. See if we add in this extra piece. I think it's still gonna, that first piece still gonna include the game number. See, game 5. So this isn't something we want to sum up. So what I could do here is we could also split this down. Dot split. On the colon. And then the first element of that array that gets created. Basically slice off that game whatever number colon just from the get-go. I think that might be a better solution. And then I think what I want to do is trim the white space just for good measure. Oh, actually that not necessarily necessary, because basically what we want to do down here is look for some number that's preceded by a space and then the actual string red or green, or blue. All right, let's see what happened. That was parts. So what does this look like now? Aha! So it's literally extracting that out now. So it was kind of irrelevant if we needed to include. Actually, what I could do here though is if I wanted to kind of trim off that first leading white space that gets created, I could just do it like that. That'd be fine. Boom. All right, so, well, we were focusing on this is game possible. Okay, so is game possible? Taking each game. Okay, so still having red light. Because, again, it's 3 are passing, but only because right now this function is always returning true. So it's actually not making any distinguishing, any kind of separation between what's actually passed. It doesn't have its core logic yet. So let's implement that now. So basically, all we need to do, basically we just have a large if statement. Actually, what we need to do is finish. We're going to finish this count cubes function. So what I want it to do is actually, okay, so we're matching on that. So now we have each part, right? These are the parts. Boom. Okay. But I want to, out of this helper function, I want it to return this cube set type. So what I'm going to do is I'm going to build up this object. And actually, all I need to really do is just replace, I need to extract the number and then replace the relevant keys number in this output. We've already initialized this. So what I'm going to do is do for each part of parts. So all I need to do is basically get the count and color in this array. Count, color. And it's going to be part.split via that space. Again, remember what each part is: some number, space, the actual color. And then what I'm going to do is basically do a dynamic keying. So basically what I can do is something like this. Basically colors count. I can just do this overriding like this. Color plus equals parse int of the count. Now, what's gone wrong here? Colors count pussy has any type because the expression string cannot be used to. Okay, so what I want is What I'm trying to do here is a dynamic key. So what I can do is an expression like this as key of type of colors count. Let's see. Well, let's see. What I could do instead is, instead of for each, let's do a for of. Basically what that would look like is have this logic. Actually, I think what my problem was is this dynamic key. So I need to figure out how to do dynamic keys. Basically need to pass this dynamic key color and then overwrite this value. So whatever color it is that comes out of here, color count. Here's the count. I want to add it onto there. But what I need to do is basically pass this into here. See, I can't do dot color because that value is right there. So I need to do a dynamic key, basically to overwrite this, whatever it may be. So what I want is something like the following. Let's see here. I'll comment this out for a second. So again, parts, I have color, name of color, color, name of color. Ooh, and actually I do need to switch these back around because the order does matter. Because the actual string value is in this order. But what I might want to do is well, let's see here. I could shuffle this around. So what if I did it like this? So again, I'm still going to try and return so instead I might do just 3 separate variables. So I might do let count red start at 0. Basically count red, green, blue. This is tricky though because I'm still gonna have to connect the name that comes from here, color, to the name of the variable. This is where it gets tricky. let's see. Well, we could do a couple things. Oop, just want to check if anyone was in chat. Basically, I could really use these dynamic keys. What I really want are these dynamic keys. Let's see. Let's see here. I'm going to try this again. I'm going to wrap this in a for of. So for part of parts. And I'm still going to have this logic. Okay. For, I have to declare this, let part of parts. Object is possibly null. So if it's null, we'll do nullish coalescence. Now it'll never be null. This is the Elvis operator. It's called the Elvis operator because looks like Elvis's hair, 2 eyes, little swoop hair, the question mark. But basically, it's that's the fun name, Elvis operator, for the nullish coalescence operator. It's basically to say that if what's on the left side here is ever null, make it this, right? So, is it null? Well, if it is null, and TypeScript is detecting the possibility that match could be null, and if it is, just do it like this. So that's some handling because, again, the match string method is perhaps limited like that. Okay. Now what I want is okay, so basically I had change this up a little bit. I want to change this back. So now this should be named color counts. But what I'm going to do is as key of type of so this should get me my dynamic key. And what I can now do is basically, now that's getting overridden. Hey, okay, so basically, I'm gonna move this back up here. Get rid of this. Okay, color counts. So that was count cubes. Basically what I'm gonna do here is I'm gonna log it as kind of like the before and after. Actually, I can just do it right in here. So let's do set this whole business with passing in set, that individual set, and then what the outcome of it, just so you can see it all side by side. Okay, just to sanity check ourselves here. So basically, this set amounts to red 6, green 3, blue 0. Nice. Cool, cool, cool. So basically, if we come back up to our tests, we're still not, because basically what we were testing here is game possible. So now we actually can write our core logic here. I'm just going to comment this out. But now we actually have something that looks like this, an object, where each one of these things are broken out. So now we can do something like the following. If just a big long conditional statement. And if it's false, return false. So what's this big long conditional statement going to be? Well, again, we have all these parameters here that get passed into is possible. So there's max red. So if that's true, or so if this red that actually got counted up is greater than the max red, if that's true, or the green is greater than the max green, or blue greater than the max blue. If any of those are true, and again, this is a disjunction, so if any one of these are true, the whole thing is going to be true. So then we want to return false. Cool. Sweet, sweet. Okay. Two failing. So why is this still failing? Let's see here. So false, false, false. Well, I could even do something like, for instance, if they were all true. So a disjunction is true if at least one of them is true, is only false if they're all false. So we could even do else return true. Again, right now those three are only passing because it's like it's always going to be true unless it's false, but we can actually put that right in here. They should all be failing now. Ah, I see now. So we could rewrite this if statement. Basically return. We could do a ternary. So is this true or not? If it's true, false. If it's not, true. Now they should all be failing. Okay. What is going wrong here? We could do... I'll just swap that back out. Cool. Okay, 2 failed, 1 pass. Okay, so why is this still not working? Let's put these back. So what I'm going to look for is... Okay, set. Was this set? 1 red, 2 green, 2 blue. Actually, don't even need this right here. I could even do this business, but I could index it. Basically, it's going to show what game. Maybe that'll give us some insight as to what is happening. So game 4, those are the sets. So game 4 should be failing. What I could do is just to sanity check, again, because each of these are their own discrete statement, just to make sure that that's not the problem. Okay, so why game 4 should be false because of 15 blue, right? So game 4, let's take a hard look at game 4. Let's take out... I think what I need to figure out here is... I'm going to set that to the side. I'm going to put this right down here. 5. Okay, so basically what I'm looking at is game 4 has 3 sets. Okay, yes, I see the problem. So basically 15 blue over here in this embedded in this string translated to 5, just 5. So there's a problem with our regex. There's a problem with our regex, and I think it happens right here. So this is just looking for a single digit. I want to look for more than one digit. I think that's actually the whole problem. Hey, there it is. Red light, green light refactor. Okay, cool. Great. So now we can move on to this test. Okay, so we have that sorted. Count cubes. Is game possible? And now we can do sum of possible. Basically now we have a way to distinguish game that's possible, game that's impossible. We have 5 test cases that are confirming that. And I can even remove this log here. Let's see, how are we on time? I'm going for 90 minutes. Alright, so let's see if we can wrap this up now. So basically, sum of game IDs. What we'll do is basically we'll pass in params like we did up here, just for good measure. But what's also going to go in here is an array of basically these cube sets. So what we can do is basically we'll start with this sum. Let sum equal 0, we'll return sum. For our test, so should calcorrect sum of truly possible. And what that's going to look like is basically very similar to the first one. So we've imported some possible game IDs. Copy this. Instead of this, it's going to be this function. Now, what's going to go inside of here is game data. So the entirety of this whole thing. All the games. And I'm going to call this param. I'm going to pluralize this just for, this is called games data. Games data. Games data takes in a parameter called games data. That is a array of strings. Cool. And what it's going to do is iterate over this game's data. So we'll do a for of single game data, games data. Basically what we're going to do here is extract the game ID. This is what we wanted to do all along. It's going to be parse int game data dot split, pretty much what we did up here. We need to get the game number. So it's basically going to be this. I should say the 0th index. We're also going to do some more string manipulation. So basically it's going to be this. 0th index. We also want to do is replace the word game with nothing. So we just have this number. We can parse int that whole thing. Again, our input text, game space something. Game space the actual number, and that's going to get to, so basically this is just going to give us the index number of the game. And then what we can do, if is game possible, we'll take in game data. Each of these params, max red, max blue, max green. It's going to run that function. And then, basically, only if because this returns true or false, right? So, our sum is going to be, this is our running total, but it's going to be summing up the game ID. Oh, I think my problem here is that, okay, so basically coming back over here. Okay, so for this example, the winning games are 1, 2, and 5. So 1 plus 2 plus 5 is 8. So I want this to be 8. 8. Hey, very nice. So there's one test suite. It has 6 passing tests. So we've confirmed that for all these test cases, that is passing. That that should calculate the correct sum. So we know they're all passing, or I should say it's passing. It's able to detect from the test cases which one's true, which one's false. Based on that, it's able to correctly calculate a sum. So great. Now we've confirmed this is going to work for really anything that could be thrown at us. So now what I'm going to do is I'm going to call this main.js. So there's game.ts. I'm going to call this main.ts. And it's going to do something similar. If I go back to day 1, basically it's going to look identical to what this function did. This is a read and calc function. I'm basically going to copy this verbatim. Just about. So in my main, so I need basically, I need this function. Some possible game IDs. some possible game IDs that's coming from game, and it's being used right here. Document data. Document data is right here. So now if I run this, npm run dev. Oops. Okay, what I really want to do is I need to provide these parameters. Because again, recall that from the test. Basically, I need to pass in this. Let's see if that's going to work. What I want to do is the file path, I want it to be day 2's data. And document data. What's gone wrong here? Argument type string is not assignable to parameter array of strings. I think the problem is so this is one big. Basically, what I need to do is parse this as so this file. I need to. I'll say it like this. This is like our whole document. Then our document data is basically the document, but with this string manipulation via the new line character. Almost there. Let's see. No such file or directory. So I'm running this. I'm in day 2 actually. So I want to change this to. So I'm in day 2. I'm in day 2's package JSON. I'm running main. This path should work. Hey! Okay, now, final sum of possible games IDs in equals 2,902. All right, let's see if this works. Oh, your answer is too low. If you're stuck, make sure you're using full input data. There's also some general tips on the About page. So this is not correct. So, let's see, where did we go wrong? Let's see. It is too Whoa, they said. So what went wrong here? Let me just triple check my data. Twelve, 13, 14. Some possible game IDs. Let's see. I think what I really want to do is, let me check that this is right. This is the game IDs, right? This could be setting me astray. This has got to be it. We did so much battle testing. I just want to see this. I want to see what this outputs. $199. Okay, so it's not an issue with, like, we're extracting the ID properly. The problem is in is game possible. Actually, so I'm gonna do this. But is game possible? Something's gone wrong here. So what I'm going to do is, my question would be is, in this actual raw data, are they throwing any curveballs that I'm not seeing? Could spot check a few. I'm going to do set. Let's just kind of examine this in batch and kind of spot check any one of them. Okay, so like for this one, well, okay, I'm going to console log. So this is game impossible. Am I right on that? Let's see. So is game possible? If any one of these exceed this number, we would know that would be the flag that it is impossible. Let's see. Game impossible. whatever reason, it is not... I think it's marking them all as possible for some reason. I think it has to do with the way I'm reading the data from the file. So for instance, I think the thing is actually marking them all as possible when they may not very well be. So like for instance, if I come into here, maybe I can snipe an impossible game. Like, I'm pretty sure game 11 should be impossible. I'm just going to delete these for a second. Is it correctly labeling game 11 as impossible? Oop. Whoa. What happened here? Uh-oh. Not a number. Okay, what went wrong here? Let's see. It's because this is a new line. Game impossible. Okay. It's correctly, like for this one. Again, it's our max numbers are 12, 13, 14. And that is red, green, blue. Red, green, blue, 12, 13, 14. So impossible, impossible. Impossible, that's correct. Impossible, that's correct. Impossible. Possible. Okay, so what is going... So it's correctly distinguishing them. So what is going wrong with this sum? Let's see. Let's see. What went wrong here? Let's see. So, let's see. What was the... Alright, let me restore this. So... should be less than. So my problem is that I'm counting too many ones that are over counting. So let's see here. Whoa, Oh, okay. I see it. I see my problem. All right. Got another solution here. 2149. Answer is too low. Well, I think I might just have to call it there today, everyone. But thanks for tuning in, and we'll follow up tomorrow with day 3, Advent of Code, and yeah, hopefully we'll have a follow up from day 2 here. All right, thanks everyone. Catch you tomorrow.